Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of improper integrals while trying to evaluate this problem here. Hopefully you can see that natural log of e is 1 and 1 minus 1 is 0, making it undefined. And also we're going to have a 0 plugged into here, makes it undefined as well. So we have a bound in the bottom and the top that is making the function discontinuous. How do we handle this? What we're going to need to do is pick some number in between and then break up into two integrals with two limits. We know that 1 is an element of 0 to e. E is like 2.79. So what we can do is at this point we can break it up from 0 to 1 plus the same integral from 1 to e. Now what we've got is some undefined terms in a defined integral, so let's get rid of them by taking the limit as a approaches 0 from the positive direction. This is because we're going from 0 to 1, and then we're approaching b from the negative direction, e from the negative direction, because we're going from 1 to b, numbers smaller than e. But as far as integration goes, you don't want to go through two integrals with two bounds because it's the same integral. So what you can do is you can say, let's consider the indefinite integral and leave out the bounds, do the problem, and then plug in this answer. So the moment you see a natural log in your problem and a x in the denominator, you should think u substitution because the derivative of ln is a 1 over x. So once you recognize that, solve for dx, plug in x du, and then you did nothing with this x, dx equaled to x du. Did nothing with this x, and this is my u term, raised to the fourth in denominator, so u is raised to the fourth in the denominator. Bring it up, make it a negative exponent, add 1, divide by the same thing, plug back in x, bring it down, make it a positive exponent. So that's your integral answer. If that didn't make sense, you need to review your u substitution. Now that we got the answer, let's plug it into this problem. So this is the answer, evaluated between 1 and a. Don't forget the limit. Technically, the limit should be on this step as well. And then limit between b and 1, or 1 and b. And when you plug in the top bound, you get this. Plug in the a, you get that. Again, technically, the limit should be there because I haven't evaluated it yet. And then plug in the top bound, the bottom bound. Natural log of 1 is 0. Natural log of a, if you remember the function of natural log, as it approaches the y-axis, if you remember the natural log function, does a asymptotic approach to 0, and it goes down from there, never actually touching the 0. So it's going to go to negative infinity, basically, as we approach the 0, x equals 0 asymptote. So here we're going to approach negative infinity. Minus a minus gives me positive infinity, but cubed is going to still give me infinity, whether I add 1 or subtract 1, divide by 2, whatever, it's still infinite. So I have 1 over infinite. On this one, natural log of e goes to 1. 1 minus 1 is 0 cubed, which is 0. And then natural log of 1 is 0. 1 minus 0 is 1, cubed is 1. And then when you evaluate this last step, anything that's got an infinity in the denominator goes to 0. Anything with a 0 in the denominator goes to infinity. So the 1 minus 1 cancel, and then plus infinity equals infinity, therefore it diverges. All right, so the main key is figuring out what type of discontinuity it is, being able to recognize that something either on the bounds or in between the bounds makes your function undefined. It's pretty obvious if you have infinity or negative infinity there, then we don't have to worry about it as much because we know exactly what's causing the problem. So the way you're going to recognize these is by doing a bunch of them. So as always, practice, practice, practice. Thanks for watching and have a great day.